The next question is June 2008, Module 2, Waves and Photons, and this is a question 1. It tells you that table 1.1 below gives the names of some regions of the electromagnetic spectrum or a typical wavelength within a region. The regions are not in order of wavelength. Complete the table by adding an appropriate name or a corresponding wavelength in the blank spaces. So you've had a question like this before. This time they're giving you different parts of the electromagnetic spectrum. So the first one here is a microwave. Now if you remember, microwave has got wavelengths of centimetres. You're supposed to give these in metres. So the one that we used in the lab has a wavelength of 3 centimetres. And so we'll put in here 3, but it has to be in metres, so it's by 10 to the minus 2. Now they'll allow you anything between 10 to the minus 1 up to 10 to the minus 3 up to 10 to the minus 1, so that fits in well. X-rays have very tiny wavelengths, but not just as tiny as gamma rays. And if you remember, gamma rays are in terms of picometers. So X-rays are usually by 10 to the minus 10. So I'm going to put in 1 by 10 to the minus 10. And they'll allow anything in the region of 10 to the minus 8, 10 to the minus 12. 10 to the minus 12 is of course smaller than 10 to the minus 8. 1 by 10 to the minus 7. And you know that visible light's next here, and visible light is from 400 to 700 nanometers, which is by 10 to the minus 9. And so we're going to put in a value here of 5 by 10 to the minus, so it's by 10 to the minus 7. So visible light, a suitable wavelength there would be something like 5 by 10 to the minus 7. And then the last one here, you can see it's going to fall in between visible light and X-rays. And it's got a smaller wavelength than visible light. It's 1 by 10 to the minus 7, so that must be ultraviolet light. So the next part of the question says, explain what is meant by polarization. And this question has come up many times about polarization. So polarization is of course where the vibrations of the waves are restricted to one plane. Describe how you would demonstrate that visible light can be polarized. Again, we've met this question before, and so all you would have to do is first of all explain that you're going to use 2 Polaroids or pieces of Polaroid. Place one in front of a light source. And it allows some light through. And then place a second between light source and you. And then when you rotate by 90 degrees, all light is blocked. Okay, next question. Sound is an example of a longitudinal wave. Give one property of a longitudinal wave or longitudinal waves which is different to those of transverse waves. So there's many things you could describe what a longitudinal wave is. That the that the particles vibrate parallel to the direction of travel. Whereas with the transverse wave, they are perpendicular. The particles vibrate perpendicular. Transverse wave, the particles vibrate perpendicular. Or it's probably more obvious to say that a transverse wave or a longitudinal wave can't travel through vacuum. And transverse waves can. It might be very obvious just to say that longitudinal waves can't be polarised. And transverse can.